Hey guys, in today's tutorial we're looking at assembly mates. Can be found tutorials under the question mark in SolidWorks, tutorials, pick up this window, click all SolidWorks tutorials and go to assembly mates. Now this is the last of my top 10 inbuilt SolidWorks tutorials for beginner, industrial designer, product designers. Assembly mates let you put all your parts together in an assembly and actually move them about and see what works. Mates are really crucial for being able to work with configurations, work with different parts, test the functionality of things, how things move, open, do animations, there's all kind of fancy things that you can do with mates when they're used properly. I think they're fundamental to working in SolidWorks and building your products as a designer. So that's why it's capping off our series here. Let's get into the tutorial. In this tutorial, you create a milling machine assembly. You use mates to create geometric relationships between the components of the assembly. The tutorial demonstrates bringing parts into assembly using the assembly mates, coincident, concentric, parallel and distance, using smart mates, testing them and editing. This assembly uses the following parts. Is there a link to opening them? Click here to open, yes there is. Click here to open the knee part. And we then click File, make assembly from part. All right, so we've started our assembly. If the origin is not visible, click View, Hide, Show Origins to display it. Okay, we can do that. Under Options, select Graphics Preview, Property Manager, Graphics Preview. Move the pointer over the origin. Pointer changes to a origin symbol, indicating the inference to the assembly origin. Click to place the knee. Done. When you place a component this way, the component origin is located coincident with the assembly origin, and the planes of the part and the assembly are aligned. This procedure, while not required, helps you establish an initial orientation for the assembly. You can create this type of inference with any component as you add it to the assembly. Okay, that's all great. The one thing that I would say is that this part is fixed in space. I always hate seeing that with the F. I want it to be fully defined in space. My assembly is fully defined at the moment, but not as well as it could be. I'm going to right click and float that part. I'm going to select the origin of that part, hold Control, select the origin of the assembly and click mate. And now I know there's a mate between them and that F disappears. Right. That mate here, coincident to the origin. Right, let's keep going. The feature manager design tree contains the feature knee. Here we go. Talks about the fixed state here. Click window we can skip those first three steps. We want to tab back to the knee part file, which is here. So you can click window knee, or a better way of doing this, assuming you're on Windows, which you must be, press Control Tab, and you can cycle between your open documents. Use this regularly. Control back to the knee file. Now, I don't know why it's done that, because it's asking us to insert more components into the assembly. So I'm going to close this knee file part by pressing Control W. No, doesn't want to do it. There we go. Okay, it's done. Back in my assembly, I'm going to click Insert Components, and the open dialog box shows the drive. We want to go to, so it's telling us where to go. So we want to go to C drive and then follow that directory, which is here. And it wants us to insert the saddle. Press Control to select these two components, saddle and table. Click Open. Click in the graphics area to place the components approximately as shown, and it's done. Property Manager closes. Beautiful. Examining the Feature Manager design tree. Feature tree, okay. So those next two parts that I've added in, they are now floating in space. You see that negative sign means they're underdefined. So I can move them around, basically. Now, I really don't like clutter, visual clutter in my viewport. So I'm going to turn those origin views off. I'm going to go Hide Show Origins. Don't need to see them. All right, so each of these parts here, you can actually press on this little arrow to expand each item to display the component features. So this is the features of that part file, and that one, and that one. Typically, you would keep that minimized unless you're working or need to edit or reference one of those elements from the feature tree of those parts. It's good practice here when you've got a chance to play around to move and rotate individual components. To move, so you practice moving and practice rotating. You can click Move Component or Rotate Component to drag to move or rotate components. So click move here, you can click and drag, or you can just click on a part and drag. But if you want to rotate, you should click here, click rotate, click on a part, and then you can rotate it around by clicking and moving your cursor. And we're going to save the assembly, and we'll save it in our folder with everything else. Mill. All right, next. Add mates to define relationships between the assembly components. To make selections easier, rotate the view by dragging with the middle mouse button in the graphics area. Then, after making the selection, click Previous View on the View toolbar. Other tools on the View toolbar is useful as you work through this tutorial. Select the top face of the knee and the bottom face of the saddle for entities to mate. All right, so we click the Mate tool here, clicking the top face of the knee and the bottom face of the saddle. The Mate pop-up toolbar appears in the graphics area. That's this little thing here. Coincident is selected in both the Property Manager and the pop-up toolbar. You can see that here because it's kind of depressed. It's got a slightly different color. You can see this here. This is also depressed in, selecting that one. A preview of the coincident mate appears, which means the parts have been moved together. And you can see those two blue planes are now touching. If the mate pop-up toolbar does not appear, select Show Pop-up Dialog under Options in the Property Manager. So that is down here, Show Pop-up Dialog. To see how you can flip the alignment of the saddle under Mate Type, for Mate Alignment you can click Aligned, which is this button here, and that will flip them around. Vectors normal to the selected faces point in the same direction. Click Anti-Align to swap them back. Press Tick to accept the mate. And the face of the knee and the face of the saddle now lie in the same infinite plane. The mate appears in the Property Manager under Mates. That can be found here, and it is coincident 2. Okay, let's continue. To test the saddle and knee mate, click Move Component and drag the saddle. We can just click on the parts. We don't need to click the Move Component tool. So just click and drag, and you can see as I move it now, it's actually staying in line with that other part. If I rotate it, try rotating it, I can only rotate it side to side. I can't rotate it sort of over the top. I'm going to add another mate between the saddle and the knee. So we're going to click the Mate tool, click Keep Visible here. That's going to keep the Mate tool open while we're working. I'm going to select the corresponding angular faces of the saddle and the knee as shown. So I'm going to select this face and this face, and I'm going to press OK because I want a coincident relation. The angled faces are now mated, and what that means is I click and drag this. Now, instead of going side to side, it's only going up and down along that angled face. Mate the table and the saddle. So this goes through the same process of mating the other one. So I'm going to select that face there, that face there. Also going to select the angled faces. So you can do 2 mates or more at the same time. You don't need to close this mate tool. You can do as many mates as you want. And so typically in assemblies, you bring all your parts in together at the one time and then try and do all the mates, as many mates as you can, again, at the one time. It's a quicker process. Press OK, and now you can see this one is sliding up and down there, and they're both staying aligned. But what is not happening at the moment is there's no limits to these mates, so it can just slide right off the edge. Okay, so that's probably one of our next steps to refine the assembly. We've already done that one. Now, adding mates to lock the table and saddle positions. You can add limit mates, which allows the saddle and table to move, but only within a specified range. However, limit mates can slow performance significantly. Use limit mates only when required. Instead, add mates to lock the saddle and table in position to prevent unexpected movement of these components. Mate the right plane of the saddle to the right plane of the table. So that is table and saddle. So I just press the plus or expand on those part files. I'm going to select the right plane of the saddle, hold Control, select the right plane of the table. I can right click and press mate, press OK. It's going to make them coincident. Right, so now that table is lined up. Very good. Mating the front planes of the saddle in the assembly. In the flyout feature manager design tree, now that's if we hit the C key, select the following entities to mate. The front plane of the assembly mill, that's the front plane here, and the front plane of the component saddle here, these ones. We're going to press mate. Now in this one, we do not accept the coincident mate. Instead, we're going to add a distance mate. A distance mate will move that part or the distance between those parts to be whatever distance we put in. In this case, 250 millimeters. So I hit this icon here for distance and I type in 250, and now I could press the tick. To see how you can flip the direction of the dimension, select and then clear flip dimension several times. So that is this button here. Oh, sorry, this one, flip dimension. That's where you can move it from one side to the other. This button here, flip alignment, is a little bit different. Just trying to, don't think this is a good example to explain how that flip alignment works, because it doesn't appear to be working. Flip alignment, if you had a part that was like not symmetrical, okay, or you had circular part, like a bolt going into a hole, sometimes the bolt's on the wrong side of two circular mates, so you need to flip one so it's going the right way in. I'm sure there'll be examples somewhere that we can see of that. I'm going to press the tick, and now if we have a look at our feature tree and our mates, we can see there's no longer any minus signs next to those parts. They are all fully defined through these mates here. Fantastic. Let's save and let's keep going. Now, renaming the mates. You can rename the mates to make them easier to find. In the Feature Manager Design tree, expand mates. Pause click on the last coincident mate in the folder, this one, and so kind of double click but slow. Enter table lock to rename the mate and press enter, and rename the distance mate saddle lock. Right click mill at the top of the Feature Manager Design tree and click collapse items. Okay, all that did was collapse. Like if you had stuff expanded, it would just collapse everything. Yeah, save. Okay, cool. Using File Explorer to add components. Another way to add components to the assembly is to drag them in from File Explorer. All right, we can do this. So we're going to open File Explorer. Start and E is an option to shortcut to open that. I'm going to browse to that folder. So once again, C, users, public documents, SolidWorks 2022, samples, tutorial, assembly mates. These are my parts. So click each item listed below individually and drag it into the graphics area. All right, so the head, gonna put it over here, bracket here, scale here. Minimize that in case I need it again. You can hide the table to make it easier to make the bracket and the saddle. So I can click here on the table. I can, on this pop-up, I can go to this tool here and click hide component, and that is going to hide that part from my assembly. The icon in the Feature Manager Design tree changes from solid to hidden. That's what you can see here on this part. You can see the difference between solid and hidden. All right, we're going to add some mates. So we're going to add a coincident mate between the back face of the bracket, the front face of the saddle, and the top face. Tick. That wants a distance mate. All right, now we accidentally here press the tick, right, as it said not to do. But you don't need to go and delete the mate. We just need to go and edit it. So you can see here in this folder, and this the selection box here, these are the mates that we're about to add. Or we have added, we just haven't pressed the tick yet. But I can click here on coincident one, and I can change it to a distance mate and put in the distance and flip the dimension to make sure that it is below the saddle face, 3 millimeters. And then I can accept the mate. And then add a third mate between the bracket and the saddle. So it wants a coincident mate between the right plane of the bracket and right plane of the saddle. So right plane of the bracket, right plane of the saddle, coincident, okay. All right, now let's keep going while we're at it. Positioning the encoder head. Add mates to position the encoder head on the bracket. All right, now here's a little tip as you're working with the mates. When you click on something, it's gonna, if the mate tool is open, it's gonna add it as a mate selection. But if you click and hold your mouse button, you can click a part and drag it to a rough position before you do that. This can be useful to drag and lift a part higher or lower, so you can then turn your view around and see the face that you need to select. Because in this case, I want to select this bottom face, turn my view, and then select this top face. Tick. Add a concentric mate. You can add a concentric mate between a hole in the bottom of the head and the corresponding hole in the bracket. Now this tells you how to use the select other tool to select one of the holes in the bottom of the head. This is actually quite a handy tool and I never use it. Maybe I should. We're going to just bring that a bit closer. Right click the side face of the head approximately over the hidden hole and press select other. Oof, that's good. The side face is hidden so you can see the faces underneath. The pointer changes to what looks like a left button click, right button show. The select other dialog box appears with a list of the items that are beneath the pointer when you right click. Hover the pointer over items in the list to highlight the items in the graphic area. Okay, it's just that face. We don't want that face though, so I'm going to deselect it and try again. All right, now This time I've got a few more options and I can find a face, and now it's going to select it. If the pointer is not directly over the hidden hole, when you right click, the hole does not appear on the list. However, you can highlight the hole in the graphics area. All right, we've got it selected now. We can go and select the hole here, accept the concentric mate, define the position of the head, add a mate between the head and the saddle. And what this is to do is stop this from twisting around. So all we want to do is select this face here and this face here, and it's going to make them parallel. Press OK. All right, last part, mate the head scale with the encoder head. So add a concentric mate between the scale and the cylindrical face. Leave the scale free to move back and forth. Okay, press the tick to close the property manager. Now right click the table and click show components. Show, save the assembly. Okay, looking good. Using smart mates. With smart mates, you can create mating relationships automatically by inferencing the geometry of existing components as you drag new components into the assembly. Here you create a concentric mate and a coincident mate automatically. We're going to open pillar file. Let's just browse to that folder we kept open. I'm going to copy that directory. So here's another tip. I don't want to click and drag this on the SolidWorks. I want to open it from SolidWorks. So I click in this window here on that directory, and I can Control C to copy that. I can then, in SolidWorks, press Control O, type in the navigator at the top, press Control V, press Enter. It's going to take me to that same folder. And now I can find that part, pillar, and press Open. Click Window, Tile, horizontally, so you can see the part and assembly windows. In the assembly window, change the view to isometric. Zoom to the hole near the right of the table. In the Feature Manager design tree of the pillar document, that's the top one, select Extrude To. Drag the feature name into the assembly document and hover and over the hole. Oh my goodness, that is good. The pointer changes to a insert icon. I don't know exactly. The pointer indicates that if the pillar is dropped at this location, a concentric mate and coincident mate are created. A preview snaps into place. All right. Press Tab several times to see how you can change the alignment. I already let go. Let's try it again. Okay. Press Tab while I'm holding. So Tab, see it reverses the direction. Press Tab again, and it comes back out. Drop the pillar. Repeat steps 1 to 4 to add a pillar to the hole at the other end of the table. Okay. This time I'm going to do it a bit differently. I'm going to go from my browser, Windows Explorer here, and try and just grab and drag it in and see what happens. Nothing. There is a way that you can set up files to work like this. Just press Escape there. And that is here in this part file. I want to select this edge, and I'm going to go under Reference Geometry, Mate Reference. And it's going to create a mate reference there, which is going to be on that edge, any direction. Default should be aligned, and press OK. I'm going to save this, and I'll try it again. Yeah. So this time when I bring it in, it's going to offer me a mate between those 2 points. Yeah, so you can see it's added a concentric and coincident mate once again. So it is possible to do it straight from your Windows Explorer into the file. Close pillar, okay, and maximize the assembly window. Done. I'm going to save using File Explorer to add components. Okay. It's exactly what we just did, so skip that one. Mating the clamp, pin, and pillar. Drag the components into the approximate correct location and orientation before adding mates. This is the other parts it wants me to bring in. So clamp and pin, drag them into the approximate correct locations. I think we've got them close enough here to just mate them. Rotate the pin so it is vertical. Alright, so click on it. Right click the pin, click Move with Triad. Right click the center sphere and click Show Rotate Delta. In the box, enter 90 for Delta X. Click OK 3 times so the pin is vertical. That is a cool little tool. Again, I've never used. Get anywhere in the graphics area to close the box. Add the mates. So we're going to add concentric between these, and concentric between this, coincident between this, and then we're done. Because the scale is constrained to be concentric with the head, the pin and the clamp move within their degrees of freedom to the position shown. That's right. So now, if we're looking at these leftover parts, the ones that are underdefined, just these round ones. Now, what you'll notice is it can rotate around. If the tutorial doesn't tell you how to stop this rotation by the end, I will show you. Copying components. On the left end of the table, make copies of the clamp and pin. Hold down Control and drag the clamp from the Feature Manager design tree in the graphics area. So hold Control, click Clamp, drag. Another clamp appears, and Clamp 2 appears in the Feature Manager design tree. The 2 notation indicates the second instance of this part in the assembly. We'll do the same thing with the pin. Good thing about doing this is that they retain the same orientation that the existing parts have. So we don't need to rotate them around or flip them upside down, etc. Although here it says we do want to rotate the clamp. So I guess we'll do that. Right click, move with triad in the box, enter 90 for delta X. Okay. 3 times, click off, and then we'll add the same mates. Concentric, add a third concentric between these. Do not add a coincident mate between the end face of the scale and the side face of the clamp because that over-defines the location of the components. Yeah, that's right. Okay. Click isometric view and save the assembly. Reviewing the mates. Now you can review you can use the Feature Manager design tree to review the mates you added. It's here. These ones are suppressed. Don't know why. Interesting. I'm going to delete them because I think that's an error. At the bottom of the Feature Manager design tree, expand mates. Each mate is identified by the type, instant number, and name of the components. If you added or deleted mates or selected mate components in a different order, the names of the mates in your assembly may differ from the mates shown here. All right. So we can see the mates they've got and what we've got. It looks very similar. Now, it says click a mate in the Feature Manager design tree to see the relevant components highlight. So as you hover over the mates, it's going to show you and highlight where those mates are. Really useful tool for quick visualization. Reviewing mates for a single component. Right-click the assembly icon at the top of the Feature Manager design tree and click Tree Display View Features. Expand Pillar 1 in the Feature Manager design tree. Pillar 1, Pillar 2, Pillar 2 for us. The features used to make the pillar are displayed. The mates in mill folder lists list the mates in the mill assembly that involve Pillar 1. So that's here, mates in mill. See 3 mates. Right-click the assembly icon at the top of the Feature Manager design tree and click Tree Display View Mates and Dependencies. Tree Display Mates and Dependencies. The mates that involve Pillar 1 appear. Okay, so I had that the wrong way around before, but so I can see, okay, there's the features, and then Tree Display View Mates and Dependencies will show you just the mates and dependencies. You can use this display of the Feature Manager design tree to focus on the structure or hierarchy of the assembly rather than the details of the sketches and features. It's true. So basically an assembly editing tool. You can hide all the features. You don't need to do that. You just need to see the mates. All right. Last step, editing a mate. Change the coincident mate between scale 1 and pin 1 to a distance mate. First, we've got to find the mate. So we want to find it. To find it, we can hover all over these until we find the one around here. That one. I'm going to go Edit Feature. We're going to click then on the Dimension tool and change the dimension to 5. And flip the dimension so it's sticking out the other side. All right. That's done. Check the assembly to verify you have the required mates. Click Isometric. Right-click the mill at the top and click Collapse Items. I think everything is collapsed. Click Rebuild. Examine the components in the Feature Manager design tree. The prefixes indicate the status of the locations of the components. So we can see the knee is fixed, but we've already changed that. The scale, pillar, and pillar underdefined. All other components are fully defined. The underdefined components have a rotational degree of freedom. Their rotational positions are not relevant to the design intent of this assembly, so it is not required to fully constrain them. That is completely fair. However, I like seeing a fully defined assembly. So to fully define this pillar, we can maximize it. We can change Tree Display to show view features. I'm going to grab the front plane of that part, hold Control, top plane of the assembly, and mate. It's going to add a parallel mate between those, and that is going to stop that rotation, and it's going to fully define that part. I'm going to do the same with Pillar 2, and my scale, which is this one, I'm going to do the same with that to stop that rotating by mating the top planes together. Okay, so now my assembly is fully defined. Checking the motion of components. Suppress the table lock and saddle lock mates so you can see how the assembly components move in relationship to each other. So we expand the mates folder and we select table lock, hold Control, select saddle lock, and then I'm going to click on this button here, suppress. If you didn't see it in the shortcut, just right click and click on suppress. What suppress does is turns them off, but does not delete them. You can turn them back on later when you want to unsuppress. So select and drag a face on the table, and now we can see what that movement looks like. So these parts stay together, but they can still kind of slide all the way off. And in this case, you can see how it's sliding through There's nothing preventing it from doing that. Right click or click on those, click unsuppress, and it brings them back. Save the assembly, and congratulations, you have completed this tutorial. Well done. Now, I want to show you how you can allow that movement but still have a fully defined assembly, or at least have something that's a bit more realistic. I did like that movement. So table lock, unsuppress, side to side movement. That's the one we'll play with. Okay, so at its maximum, when this is sliding, we should hit like, we'll prevent those two from touching, right? Or actually that can go over the top, but that should hit on that face. Yeah, so what we're gonna do is add a mate between these two faces. We'll select them both, press mate. I'm gonna click on the advanced tab. I'm gonna click this, what is it called? Distance mate. I'm gonna set the minimum to 0, and I'm gonna set the maximum to 500. Press OK. All right, so it's currently at 0, but what I can do is click and drag, and I can drag this all the way out until it reaches 500 millimeters away. And you can see in this case, there's actually more room to move. So I can go back to that mate, edit it, and change that maximum. Let's just change it to 1,000. And we can drag it all the way out, but we can see on the other end, got a bit of an issue. So there's a few ways you can handle that. You could do the exact same mate on the other side as well. And then you'd be able to pull from one to the other, because that mate here wouldn't be able to go under 0. Right, that's probably a pretty easy option. An alternative is to work out what this is here when it's touching, and then change this limit mate that we just created to have a maximum distance of 675. All right, so why don't we try that one? Limit distance, I'm going to edit that one. 675 as the maximum. Press OK, rebuild, and now we can see we can move from this side all the way to this side. It's not quite there. There is 1.1 millimeter difference. Well, we can change that. We can add plus 1.1 onto that maximum. Okay, and now we can go all the way. So we can slide there to there, and that is nice. To do the same on the saddle, again, we want to, let's do like a coincident mate on these edges, and then work out what the distance is I'm measuring from this face to this face. It's 195.2. So that mate we just added, we can do a limit mate. What did I say, 195.2? Now it's going the wrong direction, but if I right click here, and click flip dimension, it's going to go the other way. So now this has a limit and this has a limit, and my assembly remains fully defined. All right, hope you enjoyed this tutorial. See you in the next one. Thanks for watching this video. I hope you found it helpful and found something new to enhance your SolidWorks skills. Don't forget to subscribe to Fully Defined for more tutorials, tips and insights from a certified SolidWorks expert. Hit the bell icon so you never miss an update. If you have any questions or topics you'd like me to cover, leave a comment below. I read all comments and love hearing your feedback. Remember, with the right skills and tools, you can turn your design dreams into reality. Keep modeling, keep learning, and always fully defined.